All right, let's solve ministry exam questions about chapter 1, section 3, which is about the causes of circular motion. The first question, what is the most direct cause of car's centripetal acceleration? Car's centripetal acceleration when it moves on a flat, which means horizontal, surface in circle. So a car is moving on a horizontal circular path, so like this. So the car is on the road and this car is following this circular path. And we know that three forces acts on the car. One force is normal force by the road, Fn. Second one is gravitational force, Fg. And both are perpendicular to radius. Both Fn and Fg are perpendicular to radius of the circular path. And we know that if a force is perpendicular to radius, so it cannot contribute to centripetal force. So Fn and Fg cannot be centripetal force. The force which is parallel to the rod is point in the center, which is static friction force. Static friction force between the car's tire and the ground or the road will cause this object to change the direction. So as the direction change, of course, there will be a centripetal acceleration. So A is not correct because car is not moving on straight line path. It's moving a circular path. Car's moving with a constant velocity. Car is not moving constant velocity because direction continuously changing. You cannot say that velocity is constant. This is not correct. The force of friction between the tires and the road, yes, static friction, even force of static friction between the tires and the road can cause the car to rotate, to move on this circular path. The normal force between the tires and the road, normal force is perpendicular to the radius, so it cannot contribute to centripetal force. Answer for this question is C. Identify the force that maintains circular motion of a bobsled turning a corner. So a bobsled, when a bobsled is turning a corner, corners say that something like this. So here is a wall, and bobsled is climbing the wall as it is turning. Remember, I showed the movie about the bobsled to you. As bobsled is turning, so this bobsled climbs to the wall, and if it climbs to the walls, in this case, two forces, Fg, absolutely downwards, and bobsled is turning on a horizontal circle, and then that's why Fg is perpendicular to radius, so Fg cannot be centripetal force. But the wall is vertical, and then wall applies a force on the bobsled, which is known as the, remember, normal force. Normal force in here by the wall on the bobsled is pointing the center of the circular path. And then that's why normal force is the centripetal force here. But there's one more force because bobsled has some iron object under it, so to keep it on the ice, a kind of like friction force. That force is also balancing or canceling G. Bobsled can stay in vertical on the wall, so not sliding down, not going up. In this case, so we can say that the only force which is pointing the center of the circular path is Fn. So then, identify the force that maintains circular motion of the bobsled during turning a corner. So we are going to look for the force which is pointing the center of the circular path. So attraction of what? This is unclear. Friction between bobsled and the road? No, friction is parallel to the surface, and as bobsled is turning to the corner, it's in vertical surface. That's why friction force must be in vertical, not this. Normal force from the curved side of the track? Yes, normal force from the curved side of the track is the correct answer. And a motorcycle traveling on a flat surface turns. What is the most direct cause of motorcycle centripetal force? So it's also moving on a road, flat surface. It is in fact the same as the first question. A car is moving on a flat surface, or a motorcycle is moving on a flat surface, or a bicycle is turning on a flat surface. So all have the same diagram, force diagram. So you say that it's a motorcycle. So my motorcycle is something like this. So it's turning. Again, three forces act on the motorcycle. One of them is gravitational force down. Because surface is horizontal, Fn is acting up to the sky. And the third force is the static friction force, acts parallel to the surface rod. And of course, static friction force is pointing to the center of the circular path. That's why static friction force must be the centripetal force in here. The friction force between the tires and the rod, this is the correct answer. Total weight of the motorcycle and rider, not Fg is perpendicular to the radius, so it cannot be centripetal force. Normal force between the motorcycle tires and the road, this is not correct because normal force is perpendicular to radius as well. This is not correct. None of them is, so the correct answer is A in here. One of the following equations is not true to calculate centripetal force. So the first equation is down, which is not correct, but second one is correct because we know that centripetal force, according to second law of motion, second law, centripetal force must be equal to force mass multiplied by acceleration. This is correct. And in here we inserted instead of AC r omega squared. This is also correct. In here we inserted equivalent of AC, which is Vt squared over R according to tangential speed. This is also correct. So the one which is incorrect is A. The angle between the direction of centripetal force Fc and tangential velocity is, yeah. In fact, this is so easy. Tangential means tangent to the circle. Tangential means tangent to the circle like this. Centripetal means towards the center. So Fc. Always two quantity, if one of them is tangential, the other one is centripetal. So they will be perpendicular to each other. So that's why angle between these two quantities always will be 90 degrees. And next one, which of the following represents Newton's second law in circular motion? Newton's second law, remember, sum of the force acting on the object is equal to mass times acceleration. So this Newton's second law must is this. So we are going to write this in turn according to circular motion. In circular motion, we have centripetal force and we have centripetal acceleration. So which one is F is equal to m times AC? This one, C is correct answer. So the first one is A is in chapter 2, we will learn it. Also, we will learn in chapter 2, and we will learn that this tree belongs to chapter 2. We will learn about it. But this is the Newton's second law for in circular motion. A car traveling at 15 meters per second on a flat surface turns in a circle with a radius of 25 meters. The most direct cause of car centripetal acceleration, same again in this question, first question, third question, or seventh question, or I'm talking about an object is turning on a flat surface. So if the surface is flat, the centripetal force is the static friction force, or force of friction between the tires and the rod. Directly you can circle it. Force of static friction or force of friction between the tires and the rod. C8, blah, 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 is the resultant effective force on a body that moves in it in a circular path and directed towards the center of the circular path. This is the definition of the centripetal force. Centripetal force is the resultant effective force on a body that moves in it in a circular path and directed towards the center of the circular path. 9. Which of the following is directed towards the center of the circular path? Directed towards the center means centripetal. So centripetal. So whatever in the choices there must be a centripetal as a word. Tangential, along the tangent, not towards the center. Tangential, not tangential. Tangential, not tangential. Tangential means tangent to the circle, so perpendicular to radius. So only centripetal is toward centripetal force. And question number 10, a copper block rests 30 centimeters from the center of a steel turntable. The coefficient of static friction between the block and the surface is 0.53. The turntable states from rest, so which means initial angular speed is 0. rotates with a constant angular acceleration alpha. This is alpha is given as 0.5 radian per second squared. After what time interval will the block start to slip on the turntable? To delta t is asked. So this initially this copper block is at rest. So the turntable is at rest. Copper block is also at rest. So remember, diagram is like this, something like this. It was and a turntable. So it's starting from rest. Initial angular speed is 0, and on this table there's a copper block. This copper block at a distance of r from the center, which is the radius of the circle, is given as 30 centimeter, which is r. And coefficient of static friction between the surface and the block is 0.53. This is mu s. So we know that this copper block will follow the circular path together with the turntable until the static friction force is not enough to keep it on the circular path. So we will find first until what speed this copper block can stay on the turntable without slipping. So we will get that maximum angular speed initially. Then we are going to get how long does it doesn't take from 0 to that speed for this turntable to accelerate. So we know that we know an Heck equation mu s for copper for a horizontal. If an object is moving on a horizontal surface, so mu s can be calculated by a Heck equation. You can get it, even you can calculate it if you remember it. For example, you are going to see in here static friction force is the centripetal force. You will write that static friction force is the centripetal force in here. You are going to add all other things. Mu s times Fn is the static friction force. Fc is mr omega squared. So mu as Fn is equal to mg in here, you are going to write mg, which is mr omega squared. So m's will simplify. So r omega squared is ac. Mu s, remember, we can get mu s ac divided by g. And then I gave this as a Heck equation for these types of questions. If the surface is horizontal, mu s always is equal to centripetal acceleration divided by free fall acceleration. This is the Heck I gave as a Heck theory. And if you don't want to do all these steps, for a horizontal surface, you can say that mu s is equal to ac over g, always. So it can be a copper block turning on a copper block moving on a horizontal surface, making a circular path in a horizontal surface, or it can be a car on a horizontal surface. It can be a bike on a horizontal surface. It can be anything which is turning on a horizontal surface in a circular path. So mu s is always equal to ac divided by g. And AC is r omega squared. We will find that omega, which is the maximum speed, because it starts from rest until that speed, the copper block stays on the turntable, divided by g. And then cross product, you can get omega squared as omega squared is equal to mu s g over r. And after that, you are going to get the square root of both sides of the equation. You will get what omega is equal to root of bracket. Mu s is 0.53 multiplied by g 9.81 divided by r is 30 centimeter, 0.3. So we are going to use calculator. So let's choose it. 0.53 multiplied by 9.81 divided by 0.3. Inside the root is 17.33. Get the square root of this answer, 4.16. So omega, 4.16 meter radian per second. So which means if copper block attains that speed from 0, it starts from 0 and then speeds up until 4.16. The copper block is on the turntable, but if speed exceeds 4.16, if it is 4 point number, for example, 4.17, so then this copper block cannot stay on the turntable, so it will start sliding and will be off the table. So this is the maximum final speed. The turntable can have, and then still couple of block is on the table. Now we will get use the kinematic equation. How many seconds does it take for couple block to use this angular speed? We know that angular acceleration is equal to omega final minus omega initial divided by delta t. Delta t is the question. We know what alpha is, so we can get delta t. Omega final minus omega initial divided by alpha. So then omega final is 4.16. Initial is because starting from S0 divided by alpha is given as 0.5. This is the alpha angular acceleration, 0.5. When you divide this by 4.16 by 0.5, you will get the answer as 8.32. 8.32 or 8.32 seconds. So check the answers. Which one is closer? 8.4 is the closest answer. So then answer must be A for this question. 11. A car rounds a circular turn with a velocity of 50.4 km per hour. Radius of the turn is 40 meters. What is the minimum value of the coefficient of static friction between the tires and the road for the car go without skidding? In fact, the above question, 10 and 11, are very similar. In 11, tangential speed is given for the car, but in the 10th, angular speed is given. So then we will use again the same Heck equation. Heck equation was like this, remember? Mu s is equal to AC divided by G. So, and then mu s is asked to you, so coefficient of static friction is asked. So mu s will be calculated. And we know what is the tangential speed is. This is 50.4, which is tangential speed. But it is kilometer per hour, must be converted meter per second. And the R is also given, so which is 40 meters, R is given. And we are going to insert them into the equation and we will find. Let's first convert this tangential speed to meter per second. Tangential speed is 50.4 kilometer per hour. So every kilometer is 1,000 meters. You will first multiply this by 1,000. And every hour is 3,600 seconds. So by doing this operation, you can get the result. So 15 point, let's use the calculator, 50.4 multiplied by 1,000 divided by 3,600, which is equal to 14 meters per second. So 14 meter per second is the tangential speed. Or directly you can convert kilometer per hour by 3.6. Always you can get the result in meter per second. And now we are ready to get mu s, and then you will insert the equation AC into this equation. Mu s is equal to AC, and according to tangential speed is Vt squared over R, it is AC, divided by G. So insert Vt, Vt is 14, but squared, divided by, this R must be written here mathematically, so you can do that, Rg. It's going to be R times G, Vt squared over R times G. R is 400 meters, multiplied by G is 9.81. But don't forget the bracket for denominator, otherwise you'll get your calculator can incorrectly answer it. 14 squared divided by bracket 400 multiplied by 9.81, close the bracket, and get the answer 0.05. 0.05 is the coefficient of static friction between the tires of the car and the road. So answer is B. Because the Earth's rotation, you would weigh slightly less at the equator than you would at the poles because centripetal force. So I'm going to draw a sphere first here because Earth is a sphere in the shape of a sphere. It's going to be like this. So this sphere is spinning about its diameter with some angular speed. This is the equator, somebody is standing on the equator, or somebody is standing at the poles. At the poles, the body is not in circular motion. And the body is just at the axis of rotation. That's why its gravitational force acting on that body, Fg, is Fn, is directly equal to Fn. We should know that normally when you step on a scale to measure your weight, normally that scale is measuring Fn. Maybe everybody doesn't know it, but this is correct. When you step on a scale, you measure Fn, not Fg. Action reaction force between your feet and the scale is measured. And in the equator, Fn is equal to Fg gravitational force. That's why you are going to measure exactly the same weight of your body. But at the equator, it's not like this, because in the equator, your body is in circular motion. You are in circular motion. So then, again, two forces acting on your body, which is gravitational force is pointing to the center of the Earth, and Fn is perpendicular to the surface. But in here, at the equator, centripetal force, there is a centripetal force. But at the poles, no. At the poles, your body is not moving a circular path. But at the equator, you are moving on a circular path, spinning, or it's turning on a circle. So the centripetal force at the equator is going to be Fg minus Fn. So because scale is measuring Fn, let's leave Fn alone. Let's get Fn alone. Let's get this negative other side positive. Let's get this positive Fc other side as negative. So it's going to be like this. Fn is equal to Fg minus Fc. You see that? Fn is smaller at the equator than the poles. At the poles, Fn is equal to directly Fg, completely exactly Fg, but at the equator, Fn is less than Fg. So reason is that centripetal force. So at the equator, centripetal force is maximum. It's maximum because it's the greatest radius, remember. So as radius is increasing, centripetal force increases. And remember centripetal force equation, Fc is equal to mr omega squared. Or this rigid object, omega is the same for every point. But at the equator is the maximum. That's what R is maximum. Centripetal force is maximum. Maximum centripetal force causes Fn to be minimum, measured minimum. And the reason is that, so centripetal force is maximum at the equator. This is the A is the answer. And question number 13. At 13,500 Newton cars traveling 50 km per hour around the curve's radius 200 meter. Find the minimum coefficient of static friction between the tires and the road that will allow the car to run the curve safely. In fact, 13 and 11 are same question with different numbers. 11 and 13. Again, you are going to first convert this tangential speed. So car is moving in a circular path, horizontal circle. So if it is horizontal circle, we know that mu s can be calculated by AC divided by G. We said there is a hack. AC should be calculated, and then we need to know what VT is in meter per second. It's given kilometer per hour. Convert it. So I told that very simple way. If 50 kilometer per hour, every kilometer is 1,000 meters. Every hour is 3,600 seconds. So if you do that, you are going to get the result as 13.9 meter per second. After that, you are going to insert the given into this equation. You are going to calculate mu is equal to AC in terms of tangential speed, Vt squared over R divided by G. And let's insert Vt squared is 13.9 squared divided by RG. R, remember I said it's going to be near G. It will go down to the denominator. R is equal to 200 meters. It's given. Radius of the curve of the circle is 200 meters. Multiplied by G, 9.81. And when you use the calculator, which is 13.9 squared divided by in bracket 200 times 9.81 close bracket. It's 0.1. 0.1. Yeah, 0.1 is the answer, which is A. And question number 14. A car rounds a circular turn with a speed of 10 meters per 5. Diameter of the turn is given. What is the, again, same question. Repeated question, but this time diameter is given. If diameter is 225 meters, so radius must be equal to diameter divided by 2. Diameter divided by 225 divided by 2, which is equal to, let's get it, 225 divided by 2, it's equal to 112.5, 112.5 meters. And the rest is the same. You are going to use again the Heck equation, mu s is equal to AC divided by G. So AC is VT squared over R divided by G. And VT is given in the equation as in meter per second. It's okay, no need to convert, 10.5, but squared. Divided by this R, remember, will go close near to G as denominator in the denominator. R is 112.5 multiplied by G 9.81 or 9.8. So 10.5 squared divided by bracket 112.5 multiplied by 9.8, close the bracket. Answer is 0.1 again. So choice is A. And question number 15. A roller coaster car speeds down a hill past point A and then rolls up a hill past point B. And a car is moving like this in this direction and then passing from point B, as shown in the figure. What is the maximum speed the car can have at point B for gravitational force to hold it on the track? So as the car is passing from point B, this car will have a speed. That speed is asked to you, but question is saying that for gravitational force to hold it on the track, yani only force acting on the car at that point will be gravitational force, Fg. It will hold it on the track. And centripetal force in here is gravitational force. This question is saying you. So gravitational force is centripetal force. I'm going to write Fc. Centripetal force is equal to Fg. So according to this question, centripetal force equation is what? So we write mv squared over r is equal to Fg is m times g. Simplify m and m, you will get v squared as rg. This is v rg. R is known, which is 15 meters. G is 9.81. Just insert that. So get the square root. So V is equal to root of RG. R is 15 meters. G is 9.81, which is equal to, then I'll calculate them. Root of bracket 15 multiplied by 9.81, close bracket, get the answer, which is equal to 12.1. 12.1 meter per second, which means this car can go safely from this point with that speed, 12.1. Yeah, if speed is greater than that, this car can no more stay on this circular path. What's going to happen if it goes on with greater speed than 12.1? It will follow a path which is larger in radius. It will fly off the road like that if speed is greater than. That is the maximum speed that still car is following the circular path, this circle. If speed is greater than, the circle will be large. It will be like that. And I think we finished. Yeah, I have finished all the questions about centripetal force or application of centripetal force in chapter 1, section 3.